Hey everyone, welcome to this talk. As was just said, we will be talking about command line obfuscation in the next 40-45 minutes or so. You may have heard of the expression, you can run but you can't hide. Well, today we will find out that sometimes you can do both. So just briefly, before we move on, who am I? So yeah, my name is Wietze. That is a Dutch name. I'm originally from Amsterdam, but currently I live in London, where I work as a threat detection and response engineer. I really do like cybersecurity. I've spoken at other conferences before. I'm involved in other open source projects as well for the entire community. So later on, we will be talking about the LOLBAS project as well. It's one of the projects I help out with. And yeah, just looking forward to sharing some of that knowledge that I also got through other resources with you guys today. So I was going to say, let's just dive right in. So command line obfuscation, right? What is that? Just a reminder, I know some of you have different levels of technical detail, so I thought let's start with the basics, command lines. So every process on your computer has a command line. Might not be much on it, but there is always a command line attached to any process you run on your computer. For example, say Notepad. I could start Notepad, just say notepad.exe. On Windows, that will simply start the program. However, sometimes it's a lot easier to just give it some extra parameters, so extra context on the command line, and that will allow the program to change the flow before the program has even properly started. So I could also say notepad.exe followed by hello.txt. That will tell Notepad when it starts to open hello.txt as file. Seems straightforward, right? On Windows, there are many more different ways in which command lines are used. You very often will see these command line switches with a / followed by one letter, multiple letters. So for example, shutdown /R. That tells the program shutdown to not only stop your computer, but also to restart it. So yeah, as I was saying, initializing parameters that allow the program to change the flow. Now, my fourth example here is another example where you see that a command line can contain everything, right? So we see here reg.exe export, then we see a registry location, and then we see a file path. So these are all different, they have all different functions, right? Now, this is the context, so that's a command line. This is how we use them. Why does this matter in a cybersecurity context? Now, if you are a threat defender, like myself, command lines are hugely useful because they tell a bit of a story, right? So from threat detection point of view, looking at command lines can really help you understand what an attacker might be doing or try and identify behavior that could be an attacker. Because if we look at these examples I gave you, but just looking at the command line, right? Just not even understanding what the processes do, but just looking at these starting commands, I can tell you what these programs are doing. The first one is opening Notepad. The second one is opening hello.txt in Notepad. The third one is rebooting the computer. And that last one is exporting something from the registry. So command lines tell a story, and that's hugely helpful if you're trying to establish what is going on. And for that reason, lots of antivirus and EDR software, so the tools defenders use, rely on command lines in order to detect possible malicious behavior. Today, we will be talking about command line obfuscation. Excuse me. Obfuscation means in this context that you're trying to hide what the program is doing. So in these examples that I gave you, those four, it's very clear what the command is intended to do. But as an attacker, you can imagine that you don't always want EDR or an analyst to understand what you're trying to achieve. So masquerading the true intention of a command you're trying to run. Pardon me. So yeah, as I was saying, that poses a problem because if I can change the command line in small ways, I can bypass potentially defensive measures like antivirus, like EDR tools, because very often these tools rely on command lines. That in itself is not bad. Like I said, it's a great source of information. But if you rely on it too much, or if you make the wrong assumptions, it can be dangerous. So in this talk, I'll be talking about Windows, Mac, but also Linux, and I will show you with very small, subtle changes how you can bypass known security tools. So yeah, for that, we're going to be looking for command line equivalents. What I mean by that is that you find a command line with, that you would normally run, but then I'm going to change small things so that the command still works, but an EDR tool might not spot it. So, as I was saying, we will start by looking at Windows, and we will look at what command lines regularly look like, and then we're going to be looking at 4 different programs as an example of how command line obfuscation can be applied there. So on Windows, there's a number of conventions. So these are not hard rules, but sort of, normal behavior of command line tools that most programs adhere by. So if you use Windows, this will all look very familiar to you. Command lines often use /. We saw that shutdown command, /R. Here's a couple of other ones. Ping /N1, cmd /C, ipconfig /all. So very often you will see command lines that have /. You may know that sometimes hyphens or dashes, these bars, are also used. More on that later. Windows is also very case insensitive. You will also know this, right? Like a file path doesn't matter if you include uppercase, lowercase characters. Windows considers it all the same. And for many command line tools that applies as well. So /all, uppercase, lowercase, combination, all works. Double quotes, also often used on the command line if you have a space in your command line argument. By wrapping them in double quotes, the program can understand that you mean a space, and it's not a separation between individual commands. So again, more on that later, because that is actually a great way to bypass security. But an important point here to make is that these are all conventions. In Windows, none of this is enforced. Any program you write, so if you write a program yourself or you use a third-party tool, the program itself decides on all these rules. It doesn't have to be case insensitive. It's just most Windows programs decide to be. And that means that there is a scope for us to make small tweaks, and that may have big consequences. So, as I was saying, we will now be looking at 4 programs. Most of you hopefully know if you use the Windows. I'm just going to show you how an attacker may use it and how you with minimal changes can successfully bypass security. So let's start simple with option characters. Hopefully you're familiar with PowerShell. PowerShell is Windows version of a bash or a scripting environment. It's used for automating tasks. It has lots of deep integrations into the system. And therefore, it is loved by attackers. An example here, I could run this command, PowerShell /command, write host %. Hope I said that right. Hope I passed the integration test. And if you execute this in your shell, it will just give that word back on your command line. %. Now, you see there the / again, which is normal in Windows. It turns out, if you run it, I hope it's not too small and too low, that works. We already knew that. But turns out there's multiple option characters you can use there. So you see there PowerShell hyphen command, and then you see what seems to be 3 more hyphens, right? It looks like there are 4 hyphens for the word command. Now, if you look at these commands, not in your shell, but in Task Manager, or in this case, Process Monitor, you will actually see these are not regular hyphens. So if you look here at the third column, you see first a /, then you see a regular hyphen, like a small bar, but then you see a slightly wider hyphen, then you see a really long hyphen, and then you see a weird one that's sort of at the top. What's going on here? Turns out that PowerShell accepts not only / and a hyphen, but also the so-called Unicode equivalents. You may know that in Unicode, there's lots of different characters. And for example, there are multiple types of hyphens or dashes. So as you see here, I also put the Unicode codes there. You see / and hyphen, that's normal. But then you see these really high values, so 20, 13, 14, and 15, which are different types of dashes. The N dash, the M dash, and a proper horizontal bar. Now, it's not normal for a program to accept these, right? In Windows, normally we only expect a program to accept that /. But by having 4 other options, this is actually allowing attackers to bypass very simple and naive detections. Because consider this detection rule. Through the course of this presentation, by the way, I will show you different sources of detection content. Open source, different vendors. And I don't mean to pick on them, but I just want to show you that it's very often not taken into account, and therefore you can bypass detections. So this one is for Microsoft Defender for Endpoint. It's taken from this website. By the way, great resource if you use Defender for Endpoint. But if you see here, what it's looking for in this detection rule, it's trying to look for encoded commands. And it does so by looking for a command line containing the word -encoded command or -enc. If you now look at the examples I just gave you, right, we know that there is 4 other ways in which you can invoke the same command with a /, with a n-, m-, and a horizontal bar. So detections like this look great, and they will work in most of the cases, but by simply replacing the hyphen with a /, you would completely bypass this detection. So as an attacker, making this minimal change, you can already potentially allow yourself to bypass detection mechanisms. So I hope that made sense. This is a very basic case, but as we go, we'll go further and further. Oh, thanks. I do need that. Cheers. All right. So let's move on. That was PowerShell. MSI exec. So Microsoft installer executable allows you to install software packages. You may have heard of this. System administrators use it a lot to install extra software on their endpoint fleet. Attackers also like to use it because they can install malicious software or sometimes even legitimate software that they use for bad purposes. So a normal way to invoke this program is to say MSI exec / package and then the name of some tool you want to install. Now, we already looked at the /, so let's not go over that. But what about other characters? We've seen that hyphen had 4 different equivalents, right? Can we do the same with letters? Turns out you can. So if you look very closely at the screenshot here, you see MSI exec / P and then a small a and a subscript a or superscript, and then regular CK, again, and small a and GE. What I'm trying to do here is install the tool AnyDesk, which is a remoting tool. But as you see, it accepted it. So again, this can be problematic. If you have a detection rule looking for installations with MSI exec, you may be looking for the word package. But if you use this small a, the command line will still work, but your detection may fail. So again, I hope you're trying to understand what I'm trying to do here. Small changes that will detect simple, naive detections. Now, let's look at a more problematic one, because this one works on a couple of built-in tools, but not all of them. This one works on nearly every of them. C-script, again, hopefully you know it, is a tool that allows you to execute VB script and JScript on Windows computers. So again, system administrators use it. It's a bit of a legacy tool, but still, malware writers love this as well, because it's present on every Windows version, and you can do a lot with it. One way to run it is this command. So cscript / no logo / e for engine, VB script, and then a command, a file path containing your VB script. In this case, my VB script might just say hello world. So look at that top one. That is just the vanilla version, right? That works. As I was alluding to earlier, double quotes are commonplace in Windows. So you could, for example, say /e : VB script wrapped in double quotes. That would still work. What you could also do is add more double quotes in different parts of that command line. So as you see here, VB, SC, RIPT does still work. And I could put them even, if you look at the bottom one, right? Basically every character is wrapped in double quotes. And for some reason, the output is still the output you would expect to be, right? if you now look in Task Manager or your EDR tool, it actually gets passed on those double quotes. So it does not live just in your command prompt. This is what your EDR tool will see. And again, this is a big problem for detection. This is another great resource. Again, if you're new to cyber, if you've not heard of this, the Sigma project, great project. There's lots of open source detection rules. And again, I don't mean to pick on them because they have great content there. But this is one of the detection rules. They are looking for C-script execution, if you look at the very top, that have a command line that contains, at the very bottom, /e:/VB script. Now, if we looked at these different versions that I just showed you on the previous slide, that first version, the original one that most people use, it would detect that. Any of the other ones, it would not detect. And we know that, this is what your EDR sees. So that means that this detection rule will be completely bypassed. As I was alluding to, this is probably the most common type of command line obfuscation you can use in Windows, because nearly every program is vulnerable to this, at least of the ones that are built in. I don't know why I have such a dry throat. I'm sorry. Cool. Now, to make it even more complete, I have a bit of a demo. So it's a video. There's a lot going on, so if you lose me at some point because it gets too complicated, that's fine. Towards the end, I'll try and wrap it up and give some more sort of like high-level lessons learned. What I thought I'd do is look at this specific DLL. Hopefully some of you here will have heard of the LOLBAS project. It's a great open source project where it tries to list these living off-the-land binaries and scripts. One of them is com.svcs.dll. So on this website, you can find many tools that are available on nearly all Windows versions that have some weird functionality. The reason this is one of them is because this DLL can dump the contents of a process memory. Now, why does that matter? Well, on Windows, you have this process called LSAS. It's probably the most important process on Windows because it does everything that relates to security. This process contains lots of sensitive tokens, sometimes even clear text credentials, but also just hashes. As an attacker, you often try to get the contents of this process because it will help you get further into a network, right? You can possibly move laterally. So with this tool, let me enlarge that. With this tool, with this DLL, you can use run DLL32, which is another built-in Windows tool. You can call that DLL, and then with this specific structure, so mini dump, is the name of the export, then the process ID of the process you want to drop, which is LSAS, followed by a path. Here it's dump.bin, and then the keyword full. So this is how you run it. And again, trust me, lots of attackers do this. They would use this specific command in an attempt to try to dump credentials. So naturally, as a threat defender or as an antivirus software, you try to detect and block this. Now, in this demo, it's a video. I'm going to walk you through it. You will see that Windows Defender does prevent this to some degree, but with minor changes, we can actually bypass it. So let's have a look. I'm going to need my computer for that. So the first thing we need to do is to understand what the process ID is for LSAS, right? We just saw the structure that we need. So I'm going to do that shortly. And then let's start by just executing the command as it says on the LOLBAS website, right? What happens if we do that with just vanilla Windows Defender? So here I found the process ID, 680, and I'm going to run it. So this is what the LOLBAS website said, right? Run DLL, com.svcs.dll, then the word mini dump, then the process ID, which we know is 680, then a file path, which I call variant1, because it's my first attempt, and then the keyword full. Now, if I run that, Windows Defender tells me you can't do that. That's not safe. So it says access is denied. So sadly, you see on my left-hand side, no file was created. Now, let's try to make some small changes, because there's, again, with the knowledge we have from the previous examples, there's a few things we can do. Oh, I'm going to move this forward. Let's try this. So if you use run DLL, you may know that you can also use a comma instead of a space. So that was my first try. Let's try that. Does that work? Does not work. It's still blocked. I even dropped the .dll bit, which you can also leave out if you use run DLL32, but sadly enough, no luck. Now, something is like Windows Defender is picking up on something, right? It knows something about this command line that it knows it should block. Maybe it is the process ID. Maybe it knows that else has 680, so when it sees that number, it will try and block it. So what we could try, let's go. Come on. So what we could try is simply changing the number a little bit, and then maybe we'll have success. So what I've done here, I've simply added a 0 at the start of that process ID. And if you look at the left-hand side now, we have a file, variant 2a. Another thing you can try is adding a plus sign at the start of it. And again, it does work. That seems weird, right? Because the number 680 is still there. We just represented it in a different way. So simply adding one character already bypassed this detection. So, interesting. Is there more we can do? Well, let's have a look. Another approach that we could try is using ordinals. So this is a bit more technical. We've seen the word mini dump, right, in that command line. Thanks. We've seen the word mini dump in that command line. Now, DLLs often also have a numeric representation of that function. So every DLL has functions. You can call those. We use mini dump, but you can also use the numeric version. So in this case, it's 24. You need to look that up. It's not straightforward, but once you figure that out, instead of the word mini dump, I can also use hashtag 24. So interestingly enough, now I don't need to pad that with a 0, right? If you look at the very first version, 680 still worked. So I don't know what Windows Defender is doing, but clearly it wasn't just looking for the number 680, because hashtag 24 also worked without the padded 0. However, the 24 we can also pad, so hashtag 00024 works, but also we can add the plus sign again. So now we already have 5 memory dumps over there, right? So this is what we not want to see, but somehow we did work. We did work it. Now, let's look at some more options. Can we do the same, but then with a comma? This is weird. These are the exact same commands I just run, but instead of a space, I used a comma over there. That somehow is blocked. So Microsoft Defender is aware that this trick exists, but it's only looking for the comma version, which is quite strange. What I think happened is that Microsoft found a blog where this trick was described. They saw that in that blog they used a comma, and they just didn't think about like, oh, maybe you should also look for a space, because a space also works. So there we go. That one is blocked. It doesn't matter if we pad it with zeros. It doesn't matter if we pad it with a plus. Now look at the very bottom. So I'm not padding it with like 5 zeros, but with like 15. What do you think is going to happen if I press play? You can see where this is going. So if you add enough zeros at the start of that hashtag 24, if I now press enter, that did work. So we have another file there. So again, don't ask me why, but if you add enough zeros, you can still bypass this detection. So crazy. Now, let's look at 2 more versions. Whoop. Let's clean up. So, another thing you could try. Ooh, that's long. So we looked at commas and spaces. Now, we know Windows loves the double quotes. So what if we just leave out a space? Interestingly enough, if they svcs, and then don't use a space or a comma, but just wrap it in double quotes and make it follow with hashtag 24, run DLL32 is clever enough to understand that those are 2 separate things. So I'm not using a comma, I'm not using a space, and now the command line works again. So that's another variant that we have. So we already have 7 different bypasses. That's not what we wanted. This we tried. This we tried. Oh my goodness, it's going to restart every time. Okay. This is getting even more complicated, and now we're reaching the end, I promise you. numbers. In Windows, in any programming system or any operating system, numbers are represented in memory, right? And for the computer science students, you will know there's different ways in which you can store integers. Sometimes they're signed, sometimes they can be small numbers, sometimes they can be large numbers. What I'm going to try now is an integer overflow. So these exports we were talking about, this hashtag 24, that number is what they call an there was supposed to be a name for it, a 16-bit integer. So that means there's 16 bits of data you can put in there for that number. And if you exceed that amount, basically what will happen is that the number will return to 0. So what I'm doing here is I make the number so big that it doesn't fit in the memory space, and therefore this number, 65560, in a 16-bit world, that means it will just become 24 again. So if you make the number large enough, you get an integer overflow. You can see what's going to happen now if I press play. That created an extra file. So again, because the detection is looking for hashtag 24, it's not working. But if you increase the number, now even that version with a comma that was blocked before, if you remember, right? There was one version that was blocked. By simply increasing that number, we still get the result that we want. So again, the detection here that Microsoft is using is not very resilient. Now, final one. This trick we can also apply to that process ID. Because do you remember there was one version again where the process ID was being detected? Now, process IDs are a different type of integer. They're a D word, which is an unsigned long. So that number can get really big. It's almost like 5 billion. So by simply adding that very large number to our process ID, which was 680, again, we can create an integer overflow. Windows Defender doesn't know what's going on, and we still get our memory dump. So as you've seen, we've had numerous detection bypasses. So this is an overview of all of them that we've seen. So we've seen it blocks the obvious ones, the ones that are on LOLBAS, the ones that have been blogged about. But we've seen numerous versions with small tweaks, adding 1 or 2 characters, or sometimes just leaving out a character, did bypass Windows Defender, right? Like the most used security tool, probably, because it is built in. So before we move on to Linux and Mac, what did this tell us, right? What does this teach us? So we've seen here that we had a single command that we were interested in, but we found like 15 different ways of getting that command. So there are many different ways in which you can express a single command. Now, what we've also learned is that EDR or AV tools, like Defender, are not very resilient. They were very focused on specific samples that they've seen, but they didn't take into account that you can express commands in a different way. So, both as offensive security specialists as well as defensive ones, look beyond the surface, because by making small tweaks, you can see here the difference could be between dumping credentials and not dumping credentials, right? So that's a big reward. Now, that's Windows. A bit of a mess, but as we will see, Linux and Apple and macOS are not necessarily much better. They just have different problems, perhaps on a smaller scale. So think about command line arguments on Linux. Again, those of you who use both Windows and Linux will know there is a difference. Linux does not do command line arguments that start with a / for this very simple reason that their file system often uses that, right? So on Linux, you will almost exclusively see hyphens. Often you see these single character arguments like -s, but often you also see these long form arguments. So hyphen, and then a word, or in this case, almost a sentence. So long form arguments, single character, short form arguments. What's also really annoying from a detection point of view is that often you can combine these short form arguments. So if you have -a, -b, -c, you see that you can also use -abc, and it will have the same effect. Again, if you're writing detections, this can be really annoying. Something I won't have time for today to talk about, but what is different on Linux is that arguments are not a string, but they are passed as an array of arguments. That does make a difference. Again, I won't go into too much detail, but for that reason, I would say on Linux, the problem of command line obfuscation is slightly less worrying. As we will see, there are still issues. But still, just as I said with Windows, the problem here is that these are conventions. They're not rules. There's nothing that prevents you on Linux from having a detection tool that uses forward slashes. Or on Linux, things tend to be more case sensitive, right? It's not a rule. You can, as a program writer, you can just write your own interpretation, but typically it's not. However, because programmers have their own conventions, this will cause problems. So let's start with the first one. Oh, sorry. So these are the three executables we'll be talking about: base64, XXD, and netcat or NC. So this is a very simple one. Base64 is a tool that is found on most Linux distributions. It simply allows you to encode or decode content to base64. Straightforward, right? So if I run this command, echo and then this blob, and then vertical pipe base64 -- decode, I will get the string hey B-sides. Now, as you already probably have noticed from the screenshot, you can also leave out letters from that. -- decode, deco, dec, de, even -- d works, despite the short form version being just -d. If you see all the results under that, this all works. Now, again, you might think, why does this matter, right? Because this is probably just to help users out, so you don't have to remember the word decode, or if you're lazy, you can just press enter and it still works. Again, this can be problematic. This is an open source detection from Splunk. Again, great website with lots of resources. Again, they do great work. But this is just an example where you see what they're looking for. They're looking for base64 or base64 -d and -- decode. So it would detect the top one, it would detect the bottom one, but everything in between, I hope you agree with me, will not be caught by this logic. So again, small changes, potentially big impact, because we now bypass a vendor detection. Now you might think, oh, but maybe it's just base64, and base64 is not a particularly interesting command. I agree. Could still be used, as we've seen. There is a detection for it, after all. However, this is very common in built-in Linux programs. So this is taken from Ubuntu. The versions I could find on the latest stable release, wget, curl, touch, ls, ln, many, many more. They all have something like this. So on the screenshot, you see wget, again, a tool attackers love together with curl to download stuff. And again, you see the same sort of behavior where you can leave out letters. Command still works, as you see at the bottom, but you potentially bypass detections. So again, that's problematic, right? Another example that I think is actually worse. XXD. You may not know this one, it's a bit more niche, but it is like base64. It allows you to decode and encode hex content. So it's just a slightly different alphabet compared to base64. So the characters only go up to F. So it's 0 to 9 or A, B, C, D, E, F. But what you could do, for example, here, with this string, I could pass it to XXD. I pass it two options, -P and -R. And what it will do is decode it, and it will tell me, hello, B-sides Pristina. Now, the answer is already in the screenshot, but what do you think should happen if I run this command as -P ABC -R XYZ? What should happen with any logical sense, right? It should either break because -A does not exist, or PABC is not a valid command, or it should somehow, I don't know, give you an indication that what you're trying to do does not work. However, as you can see from the screenshot, it does work. So I can execute xd-pristina-rocks, and that's a valid command, because as you can see, it successfully decoded the thing I was trying to decode. So, as I was alluding, I think this is the worst kind of software implementation of command line arguments, because what is happening here is that this software, it reads the hyphen, it reads the letter P or the letter R, and then whatever follows next, it just ignores it. It's not interested. It's not going to print an error message. It just accepts it. Why is that problematic? Well, first of all, that means that there's basically an infinite number of command line equivalents, because I can make up any sort of letter combination, command line will work, and I might bypass the detection. What is even worse is that potentially you can even fool an analyst. Some of you may be working in a SOC or have some other defensive role. What would you think if you see a command like this, xxd-print equals documents, history, read only equals true? We were saying before, right? A command line tells a story. So if you read this, you may think, okay, it's maybe printing a document and it's only doing that as read only. Well, this is all made up, right? Because we know xxd only looks at the first two characters. So as you see in the screenshot, these command lines are the exact same. It just blatantly ignores all the extra bits that I added. The lesson here, therefore, is xxd can be used to make decoy commands. I can even try to fool an analyst into thinking this is a legit action, even though I might be doing something malicious. So these wildcard style arguments are something to look out for. They're quite bad. Cool. Finally, in this Linux section, netcat. So netcat is a tool. It's present on most Linux distribution, not always, but it's often used by developers and also by malware makers because it is a great tool for interacting with network. It can make TCP, UDP connections. It can receive them, all sorts of things. So, for example, I could execute this command, which will so nc is netcat. It can then I can pass it -vz, which basically tells me be verbose and reach out for port testing. Then I pass in the IP address. In this case, I said 8.8.8.8, and then a port number 53. What this does is it tests if that IP address is reachable and if the port number is open. So in this case, it tells me yes, port 888. Sorry, IP address 8888 exists. Port 53 was open, and I could send it a TCP packet. So a great tool for just doing port knocking, for example. This command line also, or this tool also takes domains. So if you look at the bottom there of my screen, you can also call google.com 443. It will then work out that Google is available and port 443 is open. So far, so good. Now, let's talk about IP addresses. Because what is an IP address? We all know what it does, right? It allows you to talk to a different computer connected to the internet. But why do we always write it in this form where you have 3 digits, a dot, 3 digits, a dot, 3 digits, a dot? Why is that? Again, this is a convention. Because an IP address actually is just a number. It's a very big number. But no one is going to remember a very long number, right? You're going to have mistakes. You're going to end up, I don't know, talking to the wrong computer. So historically, when IPv4 was created, they came up with this dotted decimal notation. So if you look at the top command there, that's how we normally write it, right? 127.0.0.1, which is localhost. That's how we know IP addresses. Now, some programs, not all of them, also accept different notations, because ultimately, an IP address is just a number. So netcat, for example, also takes 127.1 without the zeros. Weird, right? To me, that does not look like a legit IP address. If you look at the bottom, I don't know if this is going to work. No. If you look at the bottom, you see there, the second line says connection to 1.7.1, brackets 1.7.0.0.1. So netcat worked out that whilst it wasn't a legit or not a normal IP address, it worked out, oh, you probably meant this one. That is weird, because that's not how IP addresses work. If you look at that second block, you see hexadecimal notation, which are characters up to the letter F again. Octal notation, which are digits only going up to number 7. And decimal notation, which is just numeric, right, up to the 0 to 9. So, interesting fun fact, therefore, IP address 127.0.0.1 internally actually is this number, 213.07.06.443. Interestingly enough, netcat, again, is willing to convert these numbers back to their normal IP representation. Again, I find this very strange, like how many people actually would ever use an IP address like that. Yet netcat is helpful enough to actually help you do that. And it gets worse, because it can take combinations as well. Here we see hexadecimal in normal IP notation. We see octal in IP notation, but then the really weird short notation, or even a combination of all of them. Octal, decimal, hexadecimal. And as a bonus there as well, you can pad the port number, again, with unlimited number of zeros. And as you see, all of these commands worked. What I think is worse, that it actually tells you, is like, oh, you did something stupid, but I saved the day by actually turning it into a proper IP address. So again, I think this is problematic, because this means if you enter things like IP addresses, you can make it look like something that is more like a domain name, or something that isn't even an IP address. Like, how many of you would recognize that decimal version as that being a connection to an IP address, right? It looks like something completely different. So again, from deception, this can be really problematic. And if you have a detection with a regex, for example, looking for an IP address, other than that first one, it's not going to match on any of the other ones, right? So again, you may bypass detections with this. Now, I think we need to make some progress here, because we're nearing the end of the presentation. So macOS, I think the news here for macOS is that it is Unix based. So lots of these tools have just shown behave similarly on macOS. But I thought I'd give you one more example that's specific to macOS to show you that that program isn't immune either. So yeah, very similar to Linux, same command line conventions. But there are some specific tools with unique behavior. And once again, the implementing program decides. So therefore, weirdness guaranteed. So this is my one example. ourself is a built-in tool, similar to C script, I suppose. It allows you to execute scripts in different languages, including AppleScript. Now, I've been told on Slack Overflow that AppleScript is one of the least liked languages. Poor Apple. But actually, it is quite powerful. You can do lots of interactive things with your operating system, such as display a message box. Running this command basically allows you to run any AppleScript on the command line. And here we say display dialog, hey friends, with title, waving emoji. As you see, that works. If you look very closely, though, there is a difference between what I put there and what I put in the command line. Boom. Again, very small change, but we used this trick on run-dll32 before as well. You can leave out a space by simply instantly adding a quote after the letter of interest. And again, this is a screenshot taken from the Sigma project. Once again, great project, but one of their detections is looking for ourself and space hyphen E space. And now we've seen, with simply leaving out the space and immediately putting a quote, we can bypass this detection, and therefore you might miss out on some interesting behavior. Boom. Wrap up. So what did we learn? Because we've seen a lot, right? It was all over the place, lots of technical stuff. What did we learn from this? If you're here today and you're in offensive security, you must have loved this, because what we've seen here is that it is absolute chaos, right? Small changes, possibly bypassing detections, especially on Windows, right? You could really benefit from this. So if you are doing offensive security gigs, my recommendation would be is look into this, because with small changes, small risk, you can have a really high reward. So what I hope one of the takeaways of today is that look beyond the surface. If you have a command you like to execute, but you're worried it might get detected, look for these weird anomalies that allow you to execute it anyway. Command lines are much more flexible than you think, as we've seen from that example of the LOLBAS project. If you copy-paste it, it was blocked. But just the small differences can really enable you to do it. What I would say, however, be very careful not to overdo it. So do you remember these weird little A's we've seen at the start? If you add too many of them, then the command line would just look weird. So that in itself might stand out. It might get detected because you applied too much obfuscation. So be careful. Same with the double quotes. That final one I showed you, right, had like 50 double quotes in it. That in itself is likely to get caught. So don't overdo it. That's my tip. Then the final one, defenders. If you're a defender like me, please don't cry, because it's not as worse as it seemed, and not as bad as it seemed. What should be your takeaway of today, though, command line should not be relied on. What do I mean by that? By all means, keep writing detections for command lines, because as we've seen, it does pay off. Lots of attackers don't bother changing them. What we do see, though, is that if you don't write them carefully, like the people from Microsoft, you can be bypassed. It is also really hard in their defense to account for all the different options, because these tools, by their very nature, are super flexible. So what I would recommend, right, don't overly rely on command lines, but try to find detections that work on other events. So that look at that example I gave from Netcat, right, where we were looking for IP addresses. Rather than looking for IP addresses on the command line, what's a much better approach is look for network events. Network events, after all, it doesn't matter what notation you use, they will always have the same notation in your EDR. So if you can write detections on file level, network level, DNS level, honestly, it is much more reliable than trusting command line arguments. So look for the underlying behavior rather than the command line. But finally, again, sometimes you can't, right? You have to rely on the command line in order to write detection. So my tip would be focus on resilient detection. Have a think, even if you're not sure, do I really need to hard code that hyphen or / in my detection? Maybe just leave it out. It probably won't hurt your detection. It won't get more noisy, but you would catch possible obfuscation attempts. But yeah, assume that it might be bypassed, and hopefully there is other ways in which you can detect the offending behavior. Now, finally, before I wrap up, thank you for listening, first of all. Secondly, wouldn't it be great if there was like a single resource? Because we talked about all these different examples, right? I gave you all sorts of anecdotes, different platforms, different binaries. How, as a defender, are you supposed to know which one can be bypassed with which trick? Wouldn't it be great if there was one platform? Later this year, I hope to launch an open source project that documents all these weird anomalies. So if you'd like to stay informed on that, give me a follow on Twitter. If you're not on Twitter, I'm also on LinkedIn. So I hope that really helped. Thank you for listening. And if there's any questions, ask away.
Thanks so much. That was so nice, guys. Any question? Yeah.
Thank you very much. So I have a question regarding like detection use cases. So what do you recommend? Because, for example, usage of Netcat, it's red flag. What do you think? User behaviors, would this cover those kind of attacks, or can you give us a concrete example? How can we defend against those type of attacks?
Sorry, so I understand your question. So you say the Netcat example, right? So you said like what?
For example, Netcat, for example, if I have user behavior analytics or something similar, would affect this, or can we protect or detect those activities?
Well, that's an interesting question, right? So user behavior. So you could look at, for example, anomaly behavior, which again would not depend on the command line. If a user suddenly starts using Netcat and they never used it before, could already be interesting, right? Or if you look at frequency behavior of what command line options are used, right? Maybe you will see that lots of your users connect to localhost and 127.0001. But maybe not that many go to this weird, decimal representation. So again, that's a clever way of actually bypassing this issue. It's by looking for anomalies instead. So you just rank them according to popularity, or you rank them according to, I don't know, how long the command line is, how many different characters are on there. Those are also clever ways in which you might actually detect anomalous behavior, which could lead to finding malicious behavior. So yeah, you're right. I think looking at behavior and things that stand out, anomalies, that's a key approach to actually making sure you do detect stuff like this.
Also, maybe I can share my personal experience. We have kind of same problem. We are using risk-based alerting, and it means that every time you use one of those binaries that you shown us, it will be a risk score assigned to that user. So if you misuse it, I don't know, Netcat 5 times, it reaches a threshold and you will automatically have alerts. So
exactly,
don't overdo it because you will catch.
Precisely. No, that's good advice. And it's also difficult, right? Because depending on where you work, I work for a company where we have lots of developers, right? Sometimes they will just execute netcat 100 times in a single minute, right? It does happen. Users are weird, but that's why it's still interesting to look at the behavior, right? You could still see a spike and it could still end up being legitimate. But by making sure you do detect it, so you at least get an alert, you can investigate it, and depending on, as you said, risk score, sometimes you can say, a person works in the development department, there's a lower risk score. But if it is a receptionist, to get a higher risk score, right? So taking all these factors into account is also key in making sure you detect things as early on as possible. So yeah, thank you.
Any other question? Wietze, is it defense getting better, or like these vendors like Windows, you said Mac,
Yeah, it's also a good question. I think on the whole, yes, they are getting better. So I think, again, when research gets published, defenders are very quick to actually add detections. This specific topic I was talking about today, it remains a difficult problem because often we don't know about these weird quirks. So I think on the whole, they do get better. I think there's a lot more attention for these sort of tricks. Living off the land executables probably had their popularity 10 years ago when it became really popular. They're still one of the most used tools. If you read any vendor report on the threat landscape, they will always tell you executables like I've shown you today, that is what attackers use most of the time. Not the fancy malware, not the complicated binaries that you need to reverse engineer. It's simple tools like this. So does it get better? Yes. What I would say though, I would really encourage Microsoft to stop some of these weird functionalities in these built-in tools, because that's making our lives as defenders harder, right? Some of this functionality should not be there in the first place, but because it's already present on your operating system, it's really easy for malware or attackers to actually abuse that and with minimal footprint still execute their target. So does it get better? Yes, but there's still a lot of ground to gain from a defensive point of view.
Okay. And I noticed that some of the commands, you need to have like elevated privileges, right?
Correct. Yep. Yep. So for example, when we did the memory dumping, right, you do need certain admin privileges, the system one, because it's a protected process. In more modern versions of Windows, if you use kernel isolation as well, you might not even be able to touch it at all. But that doesn't stop attackers from trying, right? So, but simply by just detecting it might again prevent you from worse things to happen. But yeah, it is important to bear in mind all these tools, right? They assume post-exploitation. Most commands work as user. Some of them require admin. But again, depending on how your organization is set up, it might not be too difficult to get to admin, right? Once you're in, there's always ways to elevate your privileges. That's again something you need to assume. If an attacker is in, assume that somehow they at some point will get to admin. So as a security boundary, that's also important to bear in mind.
Thank you so much. That was great.